Sorry. So we have discussed the for loop in the last session. Today, first one is using the nested for loop. How can we write range-based programs in a very simple way? Range-based programs, and then how we use a while loop. How we use while loop, and when we are using the while loop. We already discussed when we know exactly how many times you have to repeat the loop is a for loop. When we don't know the number of iterations, we can go with the while loop. But meanwhile, quickly I'll explain the range-based programs because it's very, very easy. See, first, let me write the code. Let me write the code checking one number is even number or not. Just integer n. So whatever the number, you can read it also, but simply I'm writing check the number is even number or not. Question mark I have taken initially. If the number is divisible with 2 equals to 0, yes, it is even number. But I'm printing simply n. N. If it is not, I'm not printing else block. Only if n is divisible with 2, we are just printing. But this is checking only one number is even number or not. Now the question is, no sir, I want to check around 20 numbers. So this code you have to write in a loop for int n is equals to 1, n less than or equals to 20, n plus plus, n plus plus. This is the way. This is the way. N from 1 to 20 times we are repeating. First, what is the n value? 1. Now inside it is checking 1 is divisible or not. No, it's not divisible. Next n value become 2. 2 is divisible. Yes, 2 is divisible. Like this, it will give you the output that is 2, 4, 6, 8, 10, 12, 14. All the values will display. All the values. This is what? This is what displaying 1 to right. Here it is. Display the even numbers from 1 to 20. 1 to 20. That is the code. Next, second code is multiple codes we are writing now. Multiple codes we are writing. Second one is for only one number. Let me take integer n, whatever the number. For this number, I'm printing the table for loop. For I is equals to 1, I less than or equals to 10, I plus plus. Multiplication table means what? If n value is a 7, 7 into 1 equals to 7. 7 into 2 is equals to 14. 7 into 3 is equals to 21 and so on. 7 into 10 is equals to 70. Like this you need to display. So we are printing that one system.out.println. Right, first one is a 7 we have to print. 7, 7, 7, 7, 7. Sir, what is 7? N. That is n. Next one star we have to print is concatenation. Is a concatenation. Next one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is I. Next concatenation equal to. Next concatenation n into I. Let me explain how this code gets executed. Consider n value is a 7. 10 times this 7 will print. 10 times 7 will print like this. Next one is a star. Same one. 10 times will print. Star will print like this. Next here I value will print. I value like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. Next here it is equals to will print. Equals to 10 times will print. N into I. 7 into 1 is a 7. 14, 21, 28, 35, 42 like this values will print. This is okay. Whatever the number you are giving, suppose if you give 13, then it will display that 13th table. 13th table will display. But my question is, please don't print one table. This we know already. So what we have to do? Just tab space, tab. For loop. Same n only you have to use. In outer loop, sir, what I am using means what? N. Why, sir, n? Because inner loop you have written using n only. So please don't miss n value. A very, very important one. Outer loop always n. For n is equals to, sir, starting from the 5th table, n less than or equal to 10 table, n plus plus. So first, what is n value? 5. N value is a 5. So come inside. 5th table will display. Next n plus plus. N value becomes 6. Come inside. 6th table will display. Next n value 7. 7th table will display. N value 8. 8th table will display. Like this it is displaying. See, n value starting from the 5th table. 5th table. See, look at this. 5th table, 6th table, 7th table, 8th table, 9th table, 10th table. Everyone thinking that range-based programs are very, very difficult. No. Range-based programs are very, very easy. Very, very easy. That is the way. Just writing this code is a one. The next one is next one. This is we have completed. Now this one is, I just want to find the factorial for one number. This one in the last class I explained clearly. I explained only one number factorial I'm finding, just one number. Very, very important. Here I'm taking n is equals to whatever the number I don't want. Suppose if it is a 5, 5 into 4 into 3 into 2 into 1, you need to find out. If n is equals to 5, 5 into 4 into 3 into 2 into 1 is 120. Of course, you can do it 1 into 2 into 3 into 4 into 5 also. It's your wish. So I'm taking first one variable int fact is equals to 1. Repeating the loop from I equals to 1, I less than or equals to n, I plus plus. Suppose 1 to 5. No, sir, I want 5 to 1. No problem. I equals to n, I greater than or equals to 1, I minus minus. Like 5 into 4 into 3 into 2 into 1. Every time the number we write like this, fact is equals to fact into I. Fact equals to fact into I. And simply we are printing system dot out dot println n factorial is, just n factorial is that value, fact value we are printing, fact value. Or why this much? Just equal to, just n corresponding factorial. Sir, what is that n value? Suppose if it is a 4, it will display the 4 factorial. It will display the 4 factorial is a 24. Sir, if I give 5, then I'm displaying the 5 factorial is 120. Is a 120 like this. Now, sir, I want to find the factorials from 2 to 8. From what? 2 to 8. 2 to 8. That is the one. Here it is. Now, same story. This is common story. So, this one, you have to put it in an outer for loop. For outer loop, compulsory n only. Don't change that. N equals to 2. N less than or equals to 8 up to 8 factorials. N plus plus. N plus plus. This is. So, if you want to write range-based programs easily, all you need to do just working with the for loop programs and while loop programs perfectly. Because once you know how to find the factorial for one number perfectly, outside all you need to add one for loop, extra for loop. That's all, not more than that. Now, whenever I'm executing this, just compile and run. Look at this, 2 factorial is 2, 3 factorial 6, 4 factorial 24, 5 factorial 120, 6 factorial 720 is giving very clearly. This is factorials from 2 to 8. Factorials from 2 to 8 that we are printing. Is a way. This is next one, prime numbers. In the last class, what I have explained, how to find the factors for the given number. Factors. Suppose I'm taking again same story, n is equals to, I'm giving suppose 6. How many divisibles are there for this 6? We already discussed. That is what, how to find the factors. Is it 6 divisible with 1? Is it 6 divisible with 2? Is it 6 divisible with 3? Like that, up to 6 itself. Is it 6 divisible with 6? So you have to repeat the loop from 1 to itself, n. I'm repeating the loop for I is equals to 1. I less than or equals to 6 means n. Don't use a 6. N. I plus plus. I plus plus. That is. Okay. Now we are finding. Here it is. How to find the factors? See, 6 is divisible with 1, 2, 3, 4, 5, 6 like that. If n is divisible with I equal to 0. First, I'll show you printing. System dot out dot println that I is a factor. Like 1 is a factor, 2 is a factor, 3 is a factor, 4 is not factor. First, I'm showing that how many factors are there. How many factors? Look at this. For 6 number, 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. Suppose if I am giving 7. For 7, how many factors are there? 1 and 7, only 2 factors are there. Sir, suppose if I am giving 19. For 19, how many factors are there? Just 1 and itself. 1 and itself, that is. Now we are printing now. Sir, I don't want to print. I just want to count how many are there. Count equals to 0. Inside, when you are counting the factor, increase that count value. Once loop completed, then print. System.out.println, how many factors are there? Count. Count I am printing. Count. Okay, now just compile and run. Look at these 2 factors are there for 19 because 1 and 19. If I give 6, total 4 factors are there. No? Total 4 factors are there. Look at this. 4 factors are there. Got it? Now, the question is, prime number means what? It has 2 factors. Nothing but if count is equals to 2. Total 2 factors are there. System.out.println, it's a prime number. N is a prime. N is a prime. Else, system.out.println, it's not prime. It's not prime. Just compile it and run it. 6 is not prime because how many factors are there? 4 factors are there. 4. See, if you give 19, for 19 only 2 factors are there. So it's a prime number. See, it's a prime number it is showing. Now my question is, if it is prime, just print like this. Just print n. If it is prime, it will print. If not prime, don't print. Why the reason? This is the code is checking one number is a prime number or not. One number is prime or not. But now the question is what? Sir, I want to display prime numbers from 1 to 20. So same story. For int n is equals to 1, n less than or equals to 20, n plus plus. See, all you need to add outside is just a loop. But before that, you must learn the internal code. This is the code for checking one number is prime number or not. If it is prime number, print it. But whenever you are adding outside just one loop, so first what is n value? 1. Then it will check if it is a prime, it will print. No, it's not prime. Next n value 2, it will check 2 is a prime or not. Yes, it is prime, so it will print. See, just compile it and run it. 2 is a prime, 3 is a prime, 5 is a prime, 7, 11, 13, 17, 19. Like this, between how many prime numbers you want, that you can simply display like this. This is the one. See here, whenever you are writing, prime is okay. But in most of the interviews, they're asking the questions, just display the perfect numbers in the given range. Display perfect numbers in the given range. So first of all, we should know how to check one number is perfect number or not. So what is the perfect number? First, as usual, just go back to view up to prime. I'll go back. Now see. Now I'll explain the perfect. Here it is. Here it is. If I'm taking one number, n is equals to 6. It's the same story. Just how many factors are there we are finding. 1 is a factor, 2, 3, 4, 5, 6, like this we are checking. Yes, of course, 1 is a factor, 2 is a factor, 3 is a factor. Of course, 6 is a factor now. So no need to check with itself actually. Except itself, remaining what all the factors, sum. Just sum 1 plus 2 plus 3 will give you the same number. If both are equal, then we can say that it's a perfect number. Sum of the factors except itself is equals to the same number. So here you can repeat the loop up to n minus 1, or you can repeat up to n by 2 because it is enough. Half of. Right after this, definitely you cannot find out, only except itself. Simple way of writing the code. So here you need to repeat the loop up to either n minus 1 or n by 2. So anything is okay. Anything. But here you are finding the sum value, not the count. We are not counting how many factors are there. We are just finding the sum of the factors. Hope you got it. Okay, right. Here, first we are taking that number 6, suppose. I'm taking the value is a sum. Sum equals to 0. Every time instead of counting, sum is equals to sum plus I. But no need to check with itself. Huh? So just write n minus 1, or you can write n I less than n. Here, suppose few people will confuse. That's why n minus 1, because no need to check with itself. Or n by 2 also will work because only half we are writing. Easy way, first this one. Then when we go to time complexity concept, then we will discuss in number of ways how can you write the perfect number code. Because how can we decrease the number of iterations to find out? In time complexity concept, I'll explain. Here, finally, after finding the sum, the given number and this sum both are equal, then we can say that it's a perfect number. Else it's not a perfect number. Now 6 is a perfect number. In the discussion we have completed, it's a perfect number will give. Now we are just printing only. I'm not printing perfect or not, just n. That's it. If it is a perfect, it will print. But now I don't want to check one number is a perfect number or not. One number is a perfect number or not. Simply here, just everything you need to write inside the for loop. I equals to n equals to 1. See, I'm finding up to 10,000. This is the question in most of the interviews they are asking. N plus plus. N plus plus. Because between 1 to 100, only one perfect number. 1 to 100, two perfect numbers are there. 1 to 1,000, three perfect numbers are there. 1 to 10,000, only four perfect numbers are there. 6 28, 496, 8128. Just imagine how to find all these things manually, how much time it will take means what? So much time for this calculation. So programmatically, it is very quick, very fast. So this is the simple way of finding within the range perfect numbers if you want to display. That is okay. So hope you understood how to write programs within the range programs. Okay. So only these practice for today. As soon as while loop completed, I told you I will start arrays concept. Once I complete arrays, then I will introduce you stack programming using arrays concept. I just simplify. But meanwhile, methods concept required. In OOPS static and instance members methods I'll explore so that we will start coding everything. Okay.